Okay, what we're seeing now is exponential and log functions or equations and being able to solve them for unknowns, in this case x. So here's two that I just made up. Hopefully it'll all work out just by applying our logarithm and exponential law. So here first we've got some exponential law. So I know, so 3 to the power of x, 9, x to the power of minus 1 equals 81. So I know that I want to try, that's written as 3, so I want to try and reduce the base as much as possible. So I know this will end up being 3 to the power of x plus 3 to the power of 2x minus 1 equals 3 to the power of 4. So now that I've got the same base everywhere, I can just bring it all down to log base 3 and turn this into x plus 2x minus 2 equals 4. So we've got 3x equals 6. So from there we say x equals 2. So all I've done, I've just applied that there. That's the type of thing you've got to be able to do. As well as that, there may be something like the how we had 3 to the power, or no, won't do 3, we'll try 2. 2 to the power of negative x plus 3 times 2x equals, I don't know, 5, for example. Let's see, so with this, then we'd rewrite this as 2 over x plus 3 times 2 to the power of x equals 5. Multiply everything by x. 2 plus 3 times 2x. Hang on a second. This isn't right. That's 1 over x. It's 1 over 2 to the power of x. Hang on a second. Let's see. Oh no, I've got to do all this deleting now. I think we could do this in real life on a real test. Okay, so this becomes, hopefully someone saw that while I was doing it, 1 over 2 to the power of x plus 3 times 2 to the power of x equals 5. Then multiply everything by 1 over 2 to the x. Sorry, just by 2 to the power of x, so I end up with 1 plus 3 times 2x times 2 to the power of x equals 5 times 2 to the power of x. So from there, we'll have 1 plus, remember if we got the same base, we add powers. So x plus x is 2x. So 3 times 2x equals 5 times 2x. Oh, sorry, 2 to the power of x. And then from there, I'm going to have to make some room. From there we say, let's see if I've got enough room over here. Let 2 to the power of x equal a. So from there we'll end up with 1 plus 3a squared equals 5a. And now it's a quadratic. So we bring this over to the other side, so say 3a squared minus 5a plus 1 equals 0, and then we solve it appropriately. And remember, if we end up with an a value equals something negative, that won't work because it doesn't matter what it is, we cannot have a to the power of x ever equaling anything negative. Okay, so that took a little bit longer than I thought, but let's have a look at a log. So with this, I'm going to take this 2 and bring it to the front because it's power. I also know that this is 3 to the power of 2, so I'm going to rewrite that thing. So I'm going to say, we'll use some blue, hopefully with enough room, so we'll say 2 log 3x minus log 2 equals 2. So I'm going to say 2 log 3x minus 2 log 3. Now I know if I've got the same base and the same thing there, I end up with 1. So I'm going to have 2 log 3x minus 2 times 1, which is 2, equals 2. And I'm going to bring this over to the other side, so I'm going to say 2 log 3x equals 4. Divide both sides by 2, so I'm going to say log to the base 3 of x equals 2. So then from there, then I'll apply what I know, and I'll raise it to the power of 3, so I'll say 3 to the power of 2 equals x, so therefore x equals 9. So they're the steps that we take. So we've got to be able to apply log laws, exponential laws, so make things the same base. So we add 3, we can make that a base 3, make that a base of 3. Once we've got the same bases, then we can just let it equal, let the powers equal each other and go from there. If we've got something like this, well then we use the log law and we put that there. Multiply both sides by 2 to the power of x in this case. And then here, once again, we've got two bases are the same, then we add the powers. X plus x gives 2x. From there, we let a equal x 2 to the power of x, and we end up with a quadratic. And like I said, if we end up with a negative, it cannot equal this thing. With log laws, we can also, so we've got to be able to move some things around. So that goes to there, that we know can be written as a power of 3. So move whatever we need around. We want to try and simplify it as much as possible. So in this case, this will end up being 1, bring it over to the other side. So we want 1 log on the left, 1 and a number on the right. Once it's as simple as possible, like we had here, then we raise it to this, then we raise this to this base. It becomes power, this becomes a base. So 3 to the power of 2 becomes 9, and that's what x ends up being. So they're the steps that we take to solve exponential and logarithmic equations.